Hello everyone, and welcome back to the channel. Today is Tuesday, April 28th, 2026. I'm diving into the archives today to introduce a trend article that caught my eye. Or wait, before I forget. Did you hear about the AI that went to the beach? Wanted to catch some neural nets. Now I know, that joke is a bit of a local minimum, but we are just going to roll with it. So today I am looking at a paper, and the title is How do AI Agents Spend Your Money? Analyzing and Predicting Token Consumption in Agentic Coding Tasks. The cool is Excel and Exafol coin 22,750 vol. It is long, but do not worry. I am here to break it all down for you. Let's get right into the thick of it. The problem this paper is trying to solve is super relatable. Especially, if you have ever used advanced AI tools and then looked at your bill, basically. We have these amazing AI coding agents, like OpenHands and others, that can read your entire code repository, think about issues, and suggest fixes all on their own. They are incredibly useful. But here is the catch. The way you pay for them is completely opaque. You tell the agent to do a task, and you have no idea how much it is going to cost until the job is done. Even worse, if the agent fails to solve the problem, you still have to pay for all the computational effort they expended. It is like hiring a plumber who charges by the hour. Gets lost in a basement for 3 days. Does not fix the leak, and still hands you a massive bill. Researchers want to know 3 main things. Where exactly are these AI agents spending all these tokens? Second, which AI models are more efficient with their tokens? And third, can an AI agent actually predict how much a task will cost before it even starts working on it? To figure this out, they did a massive study using 8 different frontier language models, and the findings are honestly mind-blowing. First off, they found that Agentic Coding Tasks are uniquely expensive. We are talking about consuming 1,000 times more tokens than standard code reasoning or chat tasks. And here's the kicker. It is not the output tokens that drive the cost. It is the input tokens. Because the agent has to constantly reread the context, the code, and the history of what it just did. The input tokens just explode, even with token caching. It is wildly expensive. Right? And then they looked at the variability. Token usage is highly unpredictable. If you run the exact same task multiple times, one run might use 30 times more tokens than another. 30 times. And you would think that spending more tokens means the AI is doing a better job. Right? They found that higher token usage does not translate to higher accuracy. In fact, accuracy usually peaks at an intermediate cost level, if the agent is spending an exorbitant amount of tokens. It usually means it is stuck in a loop, doing unproductive exploration, like repeatedly opening and closing the same files. They also compared different models. For example, on the exact same tasks. Some models consumed over 1.5 million more tokens on average than others. This means token efficiency is a trait of the model itself, not just the difficulty of the task. And speaking of task difficulty, human experts are terrible at guessing how hard a task would be for an AI. A task that a human thinks will take 5 minutes might cost millions of tokens, while a task that would take a human hours might be solved instantly by the AI. Finally, they asked the agents to predict their own costs before starting. The results? They are pretty bad at it. They systematically underestimate how many tokens they will need, especially the input tokens. It's like asking me how many potato chips I will eat in one sitting. I will say 10. But we all know the whole bag is disappearing. So, how does this compare with other technologies? With traditional software, you know the compute costs up front. We're in a server. You pay by the hour, and that is it. With simple AI chat bytes, a paper prompt, which is easy to control. But with autonomous agents, AI is deciding how many prompts to make, how much context to read, and how long to keep trying. It is a completely different paradigm that requires new ways of managing budgets. But let's talk about 3 specific application examples based on this paper. How can we actually use these insights in the real world? First example. Imagine a company deploying AI coding agents for their engineering team. Instead of just letting agents run wild, they could implement the budget or early warning system. Since we know that accuracy peaks at an intermediate cost and then drops off, the system could monitor the token usage of an ongoing task. Once the agent hits that intermediate threshold while productive work usually stops, the system pauses the agent and pings a human developer. It could say, "Hey, the agent is starting to thrash and repeat file views. Do you want to intervene?" This would save companies a massive amount of money by cutting off unproductive runs before they rack up huge bills. Second, think about the pricing models for AI platforms right now. They charge you for every token, but armed with the knowledge that some models are inherently more token efficient. A platform could offer a tiered routing service, for instance. If a user submits a task, a platform could use a lightweight model to quickly assess the out-of-us. If the task seems straightforward, it routes it to a highly token-efficient model to get it done cheaply. If the task requires deep exploration, it routes it to a more robust model that sets a strict token cap. This way, users get a more predictable pricing structure, and the platform can optimize its compute resources. Third example, this could totally change how freelance developers or agencies quote projects. Yet I say freelance and this is an AI agent to help them complete client work. They need to give the client an upfront quote by using the self-prediction methods discussed in the paper. Even if the AI underestimates, a freelancer can apply a known method. The freelancer knows from this research that lies always underestimate, so they multiply it by 3 to be safe. They can then give the client a guaranteed fixed price for the job. This bridges the gap between the unpredictable nature of AI agents and the real-world need for fixed budgets. It is fascinating to think about where this is all heading. We are building these incredible, autonomous systems, but we are still trying to figure out the basic economics of how they operate. The fact that they just keep reading the same files over and over, and they get confused is so human. It's so expensive when you are paying per word. It really highlights the need for better mechanisms to recognize when a task is unsolvable. Anyway, I hope you found this deep dive as interesting as I did. The economics of AI agents is going to be a huge topic in the next few years. Let me know what you think in the comments. Would you trust an AI with your credit card? I definitely would not. Have a great Tuesday, and I will see you in the next one.